Next up, we have got our panel session, where again we're talking about preparing for space. We've got some four great panelists here today, and in your running order, if you want to take 30 seconds to introduce yourself, and yeah, just introduce yourself. So Hannah, do you want to take it away?
Hey, hi everyone. Thanks very much for having me this evening. My name's Hannah. I'm an industrial placement student in the testing division of RAL Space, which is part of STFC. And I'm between my third and my fourth year studying mechanical engineering at Lancaster University. I work mainly in the dynamics group, which deals with pyroshock and vibration testing of spacecraft equipment. And my focus is primarily on the development of our Pyroshock capabilities, as it's a relatively new test to us, as well as monitoring machine and equipment health, which takes me beyond the dynamics group into learning about other qualification tests as well. Thanks.
Fantastic. John?
Hello, everyone. I'm assuming you can hear me. I've literally just joined. Great, good stuff. I was having technical issues, you know what it's like. So yeah, I'm John Chinner. I'm an engineer with Airbus Defence and Space. I'm based in Portsmouth. Right now, I am the faculty leader in the Engineering Academy. So my job is to make sure that Airbus has engineers with the skills they need in the future, upcoming technologies and new technologies that are coming to the market that we can use in the next 5-10 years. So previous to that, I've worked as an electrical design engineer, principal electrical engineer, and I was involved with qualification testing and some ground equipment for ships and also ground stations. And I also did qualification testing on the AstroPi Mark I payload. So preparing for space is something I think I'm still doing, and I've been doing all of my career, and I think I'll probably keep doing because every day is a school day.
That's fantastic. Thank you very much, John. Olivia?
Yes. Hello. Good evening from Austria. I'm Olivia Heider from the Austrian Space Forum. I'm a board member there and also head of the social media team within the Austrian Space Forum. And for those who don't know the Austrian Space Forum, or ÖWF, how we call it, we are a citizen science organization and have a strong focus on analog research. So we are doing simulate Mars missions on Earth. So the last one was in 2018 in Oman, where we went with a field crew for 1 month into the desert. And I was one of the lucky ones who joined the field crew and experienced how a human could live on Mars, so to say. And for this year, the next mission is scheduled for Israel. And I think analog missions are perfect a way to prepare for space, especially if we want to go to Mars. We need to train the things here on Earth so that later on Mars, everything works out fine.
That's brilliant. Thank you, Olivia. And last but not least, Thomas, you want to introduce yourself?
Oh, yes. My name's Thomas Ormston, and I work for the European Space Agency at their European Space Operations Centre in Darmstadt, Germany. My job is a spacecraft operations engineer, and I'm Deputy Spacecraft Operations Manager of the Sentinel-1 mission, part of the EU's Copernicus programme. But our job really is to fly spacecraft at ESOC, and that's my thing is flying satellites. I started out for about 7 or 8 years flying our Mars Express mission, Europe's first mission to Mars. But for the last about the same amount of time, since 2012, I've been working in our Earth observation division on Cryosat and then EarthCare, which was a satellite that's going to launch, and now our fantastic Sentinel-1 radar constellation. So very excited to be here.
That's fantastic. Thank you, Thomas. So again, there's a 30-second delay between what you can see of us talking and the chat. So if you've got any questions, put them in the chat now. And I'm going to start off and ask the panelists in running order again. Hopefully it was quite an easy question, but hopefully it will spark a bit of discussion. In your respective fields, what is the hardest thing you've come up against when trying to prepare for space?
Personally, I haven't been in the space industry for that long yet, and I haven't had that much experience. But from what I've gathered from interactions with customers and tests, the hardest part for me tends to be working out anomalies. Why have we got this particular result in a test, and what caused that? And can we prevent that in a future test, or is that something that's expected from the test item? Another thing that I would say is challenging, to say the least, is when you're dealing with customers, you have to make sure that the requirements that the customer needs and the capabilities of your test facility align, and that the IUT has the correct interface, that you can put it on your vibrating machine or on your shock machine, and that it will stay there, and it won't have any unwanted vibrations that they're getting back. We need to know that whether there's any issues with cleanliness, so it has to be kept in a clean environment, and we can work around that, and whether there's any ESD, which is electrostatic discharge interference possibilities there, so we can also prepare for that as well. So it's interacting with the customers and finalizing the test procedure to make sure that everything is correct and
Right, I'm going to pick up there then, Ryan, because Hannah seems to have finished. So for me, the hardest thing, perhaps, I think, if I think back to the things I've done, the real point where I thought I was in trouble was when I received the requirements for sending hardware to the Columbus module on the space station. I had this tiny little thing, educational payload called AstroPi, that was wanted to send up to the space station with Tim Peake's mission. And I asked for the document that gives me all the information I need to make sure that that payload will be safe when it gets there. And it arrived, and it was 2 inches thick. And it was interesting because it came from the author of the document was a company called Astrium, which ended up turning into Airbus Defence and Space. So everybody looked at me and went, "Well, you come from your company, you must surely understand it." And I realized that going through it, I had I'm an electrical engineer by trade, so I could understand some of the EMC and electrical things in there, but things like shock and vibration, off-gassing were completely new. But I'd sort of stepped forward and said that I would take a leading role in the qualification, and perhaps had to project the confidence to the customers and people around the teams that it was all going to be fine. So, picking through documentation, picking through standards, picking through requirements from customers, I find is really hard, and it's also really, really important. So you got to get it right. Yeah, I always find those things a little bit daunting.
Fantastic, thank you, John. Olivia?
Yeah, it's quite, it's not so easy to answer such a question. There are many difficult or hard things. One part is, of course, in our case, get the funding for this mission, which we are doing, because we are not the government organizations and we are not supported by government organizations. Normally, depends where we are going. For example, we got a lot of support from the Sultanate of Oman, and we will get also a lot of support of Israel, because they know it's important to do these analog missions, to be prepared for later for space missions. In Europe, I would wish that maybe the big agency or ESA could pick up a little bit up more on the analog research, because we think it's a really important tool we can use for these space missions. Another thing which comes to my mind is also that we tend not to think big. If you do these missions, which we do, we have more than 200 people involved, and most of them are volunteer people, so they don't get paid for the things they are doing, we tend not to think big enough. But you can do big things if you have the right people with the right know-how, and you have people who are really exciting about space, and also go out and talk about these things which we are doing, especially involving young people. I know, I think John is one of Thomas, I'm not sure. I hope I don't mix you up. But you do a lot of outreach and inspire young people, and that's something we need to do, because they are the next generation scientists, and that's also a thing we learned. You can even involve them with analog missions, and for example, with a junior researchers program. So they have to also think about an experiment they want to do, and we can take these kind of experiments also in our mission and do the same experiments as we do with big institutions or universities.
That's fantastic. Thank you, Olivia. And again, last but not least, we'll start with you next time, Thomas. Thomas.
Oh, I don't know. It's good. I get a chance to think about it. No, okay. As I've had a chance to think about it, I would say that for me, the biggest difficulty or the biggest challenge, especially as an engineer, is learning the power of compromise and learning how important that is in what we do, because you're always part of a bigger thing. I started working in operations on one system of a satellite, and then now I'm up at system level and I see them all and I see the compromises between them. But then we're just the operations team. You've got the design team, you've got the people that are looking at the science, you've got the political side of things and things like that. So, and everyone has competing wishes, and as an engineer, you're so focused on finding the perfect solution. And it's so natural that you think, well, if I just do enough maths or write enough documents, I will reach the ideal perfect solution. But learning that that's not always possible, and what the perfect solution is actually the solution that satisfies the most people, is a big challenge to overcome, and one that I've not completely mastered myself yet, but it's something that I think comes into every part of our everyday life at work, and probably in many other industries as well, but particularly in the big complex systems that we work on. Trying to accept what other people's point of view is and where they're coming from, and trying to accept that you're part of a big system, and that your compromises are what makes that big system work is something that I think everyone should remember when they're in the space industry.
Fantastic. And I think those lessons on compromise don't just apply to the space industry, they're wider than that. So fantastic advice there. We've got a couple of questions from the audience. One for you, John. Are AstroPis on the ISS still running? Noticed that the Twitter accounts hadn't been updated since 2017.
Good question. Well, the simple, straightforward answer with regards to AstroPi Mark 1 is yes, they are still there, still sitting bolted to the Bergen arms in the Columbus module, and still being used every year for Mission 0 and Mission SpaceLab. So Mission 0 is one of those low bar things where you can actually submit your code to fly in space. It runs every year. And if you're interested you've got a young person or a group or a STEM club around you, and they want something interesting to do that isn't going to be too difficult, I'd go to look at Mission 0. It's I think it's closed for this year now, so it's a next year job, but you can get your students to send their code to space, and those run every year along with Mission 0. So those AstroPis are still up there, still working. Thank goodness. It must have been the quality of the qualification testing that was done on them. But yeah, so the project hasn't ended. The project is still going. So with regards to Twitter, if you want to see updates from AstroPi, it's definitely the @astro_pi accounts. You might be following AstroPi Ed and AstroPi Izzy, which were the two accounts that were set up for the individual Pis that got sent to space. To be honest, I haven't seen updates from them for a while either. But if you wanted to cut through all that and get to the heart of AstroPi, it's the main AstroPi account, which is @astro_pi.
That's fantastic. Thank you, John. Okay, so now a question. We're going to start with Thomas, and then anybody else can take it. I'm putting you on the spot here. If you don't have an answer, don't worry. We'll go to anyone who can answer this. Sorry. So, I mean, based on what on your fields, what do you think is going to change, if anything, over the next decade in the way we prepare things for space?
Yeah, so certainly from my field in operations, and particularly in Earth observation operations, what's going to change is space junk, and sadly not in the right direction. Although there are some lights on the horizon. Everybody's probably heard of the mega constellations that are going up. Starlink from SpaceX being the most famous, but Starlink on its own, if they reach the projected number of spacecraft they're going to launch, is going to more than double the population of objects in low Earth orbit just with one constellation, and it's not the only one going up. And it's being approached in a lot of senses with a sort of do it first and solve things later. Not completely, and many people are working on this. But it's certainly a concern because space debris is already a problem. In fact, I almost missed this chat because we had a collision alert for Sentinel-1 just this afternoon, which hopefully nothing's going to hit us. We'll see tomorrow morning. But this is part of everyday life in operations already, is doing collision avoidance, dodging out of the way of things. And it takes a lot of effort and a lot of work. And that's with the population that we've got at the moment. With mega constellations coming, although they present a huge opportunity, we've also got to look at what risk they present and what we can do about the space debris problem, because it's already something you have to design for in low Earth orbit, something you have to operate for. And we really, really need to look at where we're going with that and not make the mistakes in space that we've made with climate change, for example, on the Earth.
That's fantastic. Certainly, I've noticed a lot of articles going around about space junk lately, so it's definitely becoming a hot topic. I'll leave it open to any of the other panelists to jump in with that about that question then.
I was going to add there that it's a funny one for me because I grew up looking at the night sky and watching satellites flying over, and the novelty of seeing satellites in the night sky hasn't worn off. And I love seeing little specks of light, knowing they're human-made machines that are up there operating. But the first time I saw a SpaceX chain of satellites going over, I suddenly thought, hang on, this is different. This is a real change here. This is space isn't crowded by any stretch of the imagination, but there's definitely going to have to be some hard conversations about this because you equate it to climate change, and I guess humans have already shown their ability to ignore the problem until it really becomes a really big problem. And unfortunately, I think this is probably going to go the same way. That there's no single regulator in the globe saying that you have to operate these things and be careful. And unfortunately, by the time those kind of regulators are stood up, it's going to be too late, and there's going to be collisions. The end point for these things is really, really bad. So the risk is getting higher, and the damage is going to get worse. So it definitely needs to be considered. And I'm glad there's so much being talked about in the public domain about this. Because it's a really, really critical thing.
Brilliant, thanks, Sean. Okay, if there's no more thoughts on that question, then Remco, did you say there was a question from the chat?
Yes, John Swift. He was initially asking this to Agnieszka, but I think Thomas can answer this as well. He's saying, as a recent master's graduate without much experience at all in spacecraft operations, etc., there are fewer opportunities for training as I'm no longer a student. What would be the best way to get it now?
You see, I'm catching up now with the questions. So it's a very good question, and it's the paradox that everybody, including me, faces when they want to get into operations, because pretty much no one learns operations at university. We learn design and things like that, but no one learns what operations is or how to get into it. There are a few ways to get in after your master's. Look at graduate programs like the YGT program that ESA has. That's how I got into operations. But also look at ways you can get in, maybe not as a spacecraft operations engineer, which is the job I'm in, but something like a spacecraft controller, which is a slightly lower position, but actually a really good graduate starting position, because you're there dealing with the spacecraft every day and looking into it. So that's what I would suggest, is just to shop around and look at the jobs that are maybe they don't feel that, maybe they feel beneath you. They're absolutely not. They're a key part of the industry. They're very exciting to do. And once you're in, and then you can work your way up. But that's always the issue with a lot of areas, I think, of the space industry, not just operations, is breaking in takes quite a bit of perseverance. You may end up with quite a few rejections, but I promise you it's worth it, because if you persevere, you can get a really exciting career out of it.
That's brilliant. Thank you very much, Thomas. I don't know whether you've got any more questions from the audience, but in the meantime, Olivia, a question for you. So obviously you do some great work with the analog research missions. how, if you had a bigger budget, what would be the next step in order to prepare people to go to Mars?
I think we would go more remote places. So at the moment we stick around Europe, I would say, because it's also feasible for us to do, and there are a lot of nice places to go. If I may share one image, maybe, I'm not sure if this works out. Just that you get a feeling why we can do that on Earth. So, and sharing is over here somewhere, I suppose, or not. Maybe you can point me here to the right direction. Okay, so for example, there's a comparison of one picture, Oman and Mars. The above picture was taken in Oman during an EVA with our spacesuit simulators. So these spacesuits we are building ourselves. So it's our own technology, our own know-how inside, and we say it's a little spaceship to wear, for example, because you have everything you need in there, your own ventilation, onboard electronics, and so on. Of course, also you have something to eat and to drink. And the picture below is taken from Mars, from probably Curiosity, I would say, at a similar time, say in 2018. And this shows you that on Earth we have really these perfect places to go where we can learn how to do things right later when we go on to Mars. And what we would love to do if we would have a bigger budget is, of course, to go more remote places. For example, one big on the wish list would be the Atacama Desert, because it's also from an astrobiology perspective, it would be ideal place to go there because there is not many vegetations and hardly any things who live there. A lot of studies from the Atacama Desert, from the astrobiology perspective, that it's really, really interesting. And we would like to go there and test if we could find life with the experiments we are using. So maybe also one other thing, the experiments we are doing in these simulations, there are some made by our organization, but most of the experiments are done by partner institutions or research institutions. So we always have an open call for experiments. So different institutions can go with us, can use us, because we are doing all the organization and bring everything to the place, and they can use us, bring the experiment there, and we will conduct then the experiments. So for example, we had a greenhouse experiment from the Italian Space Agency in 2018, and we could grow, so to say, some food, fresh food, also in the desert. So that was really, really nice.
That's fantastic. Thank you very much, Olivia. And well, hopefully you'll get the budgets in the future to be able to do that. Okay, so I've got another question. Open. Whoever wants to pick it up, pick it up. What do you think the main differences are, if any, between the way the private sector and public sector prepare for space?
I guess I can sort of speak on that from a sort of a more government-funded perspective, because RAL Space is government-funded. We're very lucky in that we are not we are given a budget every year, but we are not tied to making a profit as such. Whether it's with obviously commercial industry, it's a business. It's got to make a profit so that it can continue running and pay its staff and continue growing. Whereas with a government funded body, you've got your budget, and what you choose to do with it is up to you. You have to get the funding, obviously, from certain places for certain projects and things, but there is no entire responsibility to pay all that money back to the government. You have that money and you can put it into all the projects you want and get all the development going and everything. So it's the ways that there's the structure is, I think, between effect.
Yeah, I might jump in there at that point. Actually, it's a really interesting point that Hannah raises about the way that these businesses operate. And I remember going to the managing director of Airbus Defence and Space UK in 2015 and asking for money. This was money to do qualification work and work on AstroPi. And his response was, "What's in it for me? What do we get out of it?" Because he's built his life around business. Every pound they spend, they want to get some money back for it. And I had to say, look, what you're going to get for it is kudos and visibility. And how do you put a figure on those things? It's very difficult. And I think it's probably quite lucky that I managed to twist his arm and get him to put his hand in his pocket for things like that. But working as I do in a large organization like that, it's always about profit and loss. And I got a lot of friends in the UK Space Agency and work on some outreach programs which are funded differently. And it's a really interesting way to work, that you sit between those two things, and you almost have to write a business case for something in a way that you're almost like going into Dragon's Den. And that's quite a tricky thing to do, I think. And it's if you're asking someone for money, they want to know what they're going to get for it, and sometimes it's not necessarily profit.
Yeah, maybe I can jump in on that one as well, because we are also very, very used to make a case for companies why they should sponsor us for these missions, because they also don't get anything. Mostly they get, of course, public outreach and a lot of press, which companies are happy about if it fits within their goal they are doing. But I think also it's quite a different thing if you are a government organization like ESA. You have so many countries which are talking within ESA what to do, that you have strict rules how to do things, and you cannot jump on one thing which might be very interesting and very useful, but you just can't do it, because you have to go over all your country heads and talk with them and make a decision. So for private companies, it's much easier to go in one direction, because if, I don't know, Elon Musk says, yeah, let's go to Mars, he does it. And the people follow him, and it's much easier if you don't have, like, I don't know, ESA. How many ESA member states do we have now? I should know it, like 22 or something. Yeah. Okay, good. So it's a different approach, of course, and that's what it makes difficult for government organization, I would say.
Yeah, I would pick up exactly on that, and I agree completely with Olivia that it is challenging. Because of the structure of public organization, we sometimes aren't as agile. It's common with many public organizations as a company can be. But the flip side of that is indeed that it's easier for us to justify outreach activities or blue sky projects and things like that, because that in a way is what we're there for as a space agency. We're there to sort of try and blaze a trail and take the things that are maybe too risky for business to pick up, or what for things that there is no business case yet, and things like that. That's why we're there for. I think it's also important to say that there's actually a really blurred line between the two. Not always. I mean, sometimes you've got things like SpaceX, which are very much a corporate thing. But for example, between ESA and Airbus, or ESA and Thales Alenia Space, or any of the hundreds of other companies that we work with, there's a much more blurred line, where a lot of our projects, when we say they're realized by ESA, well, they're realized by the space industry, by business. Those are the people that actually realize the projects for us. And so it's a very symbiotic relationship there. So it's hard to say that there's a strict boundary between one and the other, I think.
Yeah,
Fantastic.
maybe just one sentence to that. I totally agree with Thomas, and I think it's also important that that we have government organization like ESA, and I'm a very big fan of ESA, of course. Maybe whatever. There's also the possibility for these industry which are working for ESA also to jump on certain aspects to different organizations and to work, for example, also with us for the Simulate Mars missions, or to work with also different companies. And yeah, that's probably one good thing that both is possible, working for ESA and working also for private things. But if we want to go to Mars, and I'm a very strong advocate for it, of course, I think also the big government organization probably would need to take more risk, and it's very hard to discuss and gives a lot of different implications, of course.
Yeah, I guess that's a very interesting point about risk appetite as well. Sorry, I just got muted there. Yeah, risk is quite an interesting thing. It always comes down to money and risk, doesn't it? It seems to be in the conversation. But I guess that's what makes the world go round, eh? So thank you very much. There were some fantastic points. I'm just looking in the chat now, and I can't seem to see any more questions. There's a lot of enthusiasm for AstroPi in the chat, I must admit. Yeah, any more final thoughts from any of the panelists before we move on to our next section?
I was just thinking about something Olivia said about going to Mars, and I often present the counter argument that going to Mars is not going to be easy, and I think Olivia's things that you're doing are proving that point. And perhaps it needs to be out, in my view at least, in the mainstream, that going to Mars isn't like, oh, we're going to go to the moon and just not get off. We're going to keep going towards Mars. It's a whole step change. It's not just going to be solved through engineering and science. It's going to be a whole lot of other things that have to be done. And just to make one point, I remember in 2009 when we were celebrating 50 years of Apollo 11, the air-to-ground radio was being replayed in real time, and I remember listening to the alarms as the astronauts were going down to the surface, and the fact that they had almost real-time comms with the Earth to fault find things. And you overlay that with a mission to Mars, and you think about those humans going down to Mars. They're on their own. They are literally going to have to fault finding and doing everything they can on their own. And they're going to have to. They cannot ask for help and expect it back. Suddenly, they're going to have to fault find and do all those things. And all those skills, all that training has to be done in the time between now and sending humans to Mars. And I think this is a great goal, and we have to embrace everybody to come on board and try and find solutions to this, because things like what Elon Musk are doing with Starship are fantastic, and he's showing the fail fast mentality, where you test something and show it exploding and go, well, we learned from that. But there's very little chance of Starship flying to Mars on its next flight. So there's a whole load of steps that need to be taken in between to get us to sending humans to Mars, and it's a journey I look forward to seeing happening. And things like what Olivia doing in the background of perhaps not seen as widely as they should, because these are all things. And I can just imagine that being in those analog suits, walking around in the desert, is really, really hard work. And I can imagine the lessons learned, the feedback you've got from that they need to be pitched at a very high level to people who are planning on going to Mars, because they're going to be critical things that you're finding out with those things.
I think I'll pick up from John for my closing, because that actually gave me some thoughts as well. And going to Mars, as you say, it's a fantastic goal. It's very difficult and very far away. And I really want to pick up on what you said, which is that the diversity of the space industry, the number of things that we look at and work on, and very many of those things need to come together to get us to Mars. And I would encourage everyone listening, and you're already doing a great thing by listening and getting involved and seeing how wide the space industry is. Sometimes, yes, Starship is amazing, and there are amazing feats, but there are so many amazing bits of the space industry, from the little ones, someone working on some amazing software code, to going out and working on Mars analog in the desert and things like that. Then you've got things like a giant robot rover that's just landed on Mars and is going to fly its helicopter. We should celebrate the big projects, but I would really encourage everyone to celebrate the little things as well, because every little corner of the space industry is fascinating for me, and I'm sure it's fascinating for all of you as well. So that would be my closing thought, I think.
Yeah, that's a wonderful closing thought, Thomas. I would encourage also people out there who are not working in space and industry, but are really interested into space. there are possibilities for you also to get working in space. So you don't need to be a space professionalist to work for space and to bring also humankind forward to Mars, for example, or to the moon, to solve the space debris problems. There are a lot of things out there where people can help, even if they don't have the education. If you're not an engineer or something, I'm not an engineer, but I help with the simulate Mars missions. And if you are out there and interested, and it doesn't matter which background you have, please get in touch with people you support. And there are ways to help bringing or preparing for space, as the motto would be for tonight. Yeah.
Yeah, I'd agree with what everyone on the panel has said there. Yeah, 100%. It's going to be a real challenge to get to Mars, and I guess from the perspective of my family, anyway, they don't know that much about it. So yeah, they're some of those people that you can talk to them and say, actually, it's a lot further than the moon. Unfortunately, it's going to take us about 7 months to get there, rather than just a few days. A week round trip and off we go. It's a lot further away, as John has said. The communication is non-existent in real time. Anyway, you've got a gap between 14 and 22 minutes sometimes of communication time that it will take to travel. So you really are on your own. It's going to take the best qualified astronauts and the most highly trained that we have, the best engineers, the best scientists, and the best of everybody to come together and pull that mission together, organize it, schedule it, structure it so that it goes as smoothly as possible. And that will take thousands of people working across all sorts of industries. And I think that's what's going to be really exciting when we finally pull it off, that it's going to have touched so many people's careers and lives, that they can say that they were part of that. So I do say that. Thank you.
That's fantastic. Thank you very much. Well, that's been an absolutely fantastic panel. We did have one more question in the chat, and I guess we've got time to answer it very quickly. A bit political, but as I say, we've already discussed money, so why not politics? Do you think ESA collaboration will be affected by Brexit?
I guess this is down to me to answer. It's a tricky one, because we do try and stay out of politics. We try and stick to the science and engineering. I think the main thing to say is that Britain is a member state still of ESA, and ESA is not directly connected to the EU. We do a number of projects together with the EU, but we were there before the EU, and we intend to stay for a very long time still. So in that sense, at least from my perspective, looking at the ESA world, I don't see a great change. The UK is very committed to space, which I think is a fantastic thing. I think it's a good thing when any country's committed to space. And they've repeatedly said that they recognise that ESA is a driving force in space for the whole continent, aside from politics. But if you just talk about the science and the engineering, that ESA is a driving force for that. So I'm grateful that despite Brexit, the ESA cooperation should remain somewhat untouched.
Yeah, and it's a really important message there, that membership of ESA is not dependent on being a member of the EU. And it's a question I get asked a lot, and I have been for a few years now. And I think that, you know, people do assume that you've got to be in the EU to be a part of ESA, and you don't. And you know, there's some very simple things we can do to educate people with this and put a positive spin on it. That, you know, yes, as the UK, we've got a thriving space industry. We do a lot of work. And we give a chunk of money to ESA to be a member, but around about 80% of the money we give to ESA comes back to the UK in contracts to the space organisations that are here. And, you know, I'm really pleased that around 50% of that 80% comes to Airbus Defence and Space. So that money isn't going to this big bad EU. It's going into the pockets of the engineers and scientists here in the UK. And that relationship is really important. And I think that relationship is probably stronger than Brexit. I think it will outlive all the talk of Brexit, and we'll continue to show all the good things we can do when we work together.
That's fantastic. Once again, thank you very much to all of our panelists. That was an absolutely fantastic panel. We've got some interesting insights there on preparing for space.